Hello wonderful person, this is Anton, and in today's video we're going to be talking about a newly discovered exoplanet somewhere out there in our galaxy that seems to redefine our understanding of how solar systems are made. We're going to talk about this new discovery, and welcome to What the Math. So this is actually not the exoplanet that we discovered, but this is a similar concept. And I actually wanted to start right here in the Space Engine just to show you what's going on. This is an object known as HATS 6b. It's a kind of a hot Jupiter, or basically a hot gas giant, orbiting very close to its parent star. We seem to have found a lot of these, although normally the star itself is very, very large, or at least as large as our sun. In this case though, this is actually a red dwarf, and it's an M-type star, meaning that it's a red dwarf that is not really massive. This one specifically is about 57% the mass of our sun, and not really that bright. So the fact that we found this planet means that it had to be very large for us to actually see it. Now, we've discovered only 3 gas giants orbiting around red dwarfs, and we think that it's actually almost impossible for a red dwarf to create a gas giant, and we think that it's almost impossible for a red dwarf to create gas giants, but we are almost certain that usually these stars will have quite a lot of terrestrial planets. So the biggest example being the closest exoplanet to us and the closest star to us, Proxima Centauri b, which is a beautiful world that's very similar to our own Earth. And we're actually discovered some of the coolest planets around red dwarfs, including, of course, the infamous TRAPPIST-1 system that has 7 terrestrial planets in its orbit. And so these planets are very common, but a gas giant around a red dwarf doesn't really make sense. And one of the reasons why it doesn't make sense is because of the way that solar systems are made. So in the beginning, at least according to our current understanding, and this is a hypothesis known as the nebular hypothesis, you basically would have a kind of a ring orbiting around a central region that becomes a star, and that ring will usually sort of create the star and the planets. And if the ring doesn't have enough material, the planets will be terrestrial, like Earth and like TRAPPIST-1 planets. And if the ring has a lot of material, you'll have a larger star and larger planets. So, it sort of makes sense, and I'm going to show it to you in a second in Universe Sandbox. But so what we've discovered in October of 2017 is yet another object that we saw passing in front of a red dwarf. Now, this object is unofficially now known as NGTS-1. We don't actually have it in Space Engine yet, so it hasn't really been added to the database, but it is a very similar object to our Jupiter. It's only a little bit less massive than Jupiter and is pretty much the same size as Jupiter and kind of looks like this. Basically like another gas giant that is somewhat similar to other gas giants that we have in our solar system, specifically Jupiter and Saturn. Now, NGTS stands for Next Generation Transit Survey, and so basically it's a new technique that we are using to look for transiting planets in front of stars. But to find a transiting planet around a red dwarf is very difficult because they're not very bright. It's very hard to see something passing in front of them. So this new technique showed us that we can actually see an object passing in front of the star, and in this case, it just happened to be a very beautiful gas giant. But of course, this created a lot of questions, and one of those questions is, how was it formed? The orbital period here is about 2.6 days, meaning that the temperature on this planet is about 530 degrees Celsius, or about almost 1,000 degrees Fahrenheit, and its mass is about 82% of Jupiter. It's a very, very massive object. Let me actually recreate this in Universe Sandbox so you get a better idea of what we're talking about here. So here we go with the recreation of this in Universe Sandbox. That kind of gives you an idea of what this object looks like in comparison to its parent star. This is NGTS-1b. It's an object that's about 260 masses of Earth, and it orbits this close to its parent star. It's obviously very hot here. It's very unfriendly to human life, but we don't really understand how it was created and how it formed so close to its parent star. So look how close they are and how relatively similar they are in terms of size. In comparison to Jupiter and our Sun, this is actually incredible. As a matter of fact, the actual barycenter between these two objects, in other words, the center of orbit, is, let me show it to you, it's going to be outside of the star. Right there, it's actually moving around the center of the star because the planet is relatively massive and it affects the motion of the star quite a lot. And you can even see the motion change right here with the velocity changes. In other words, this planet has quite a lot of influence on its parent star. And we don't really understand how this happened. We've found several other gas giants. As a matter of fact, this is the third gas giant we found around a red dwarf, an M-type star, but those were farther away. We also found HAT 6, which has a gas giant, but it's a lot less massive and it's also a little bit farther away. But this is the first hot Jupiter we've discovered that seems to have these unusual parameters, and it really makes no sense in terms of planetary creation. So we know that this could not have been captured from outside. We know that this could not have actually just been formed where it is right now, because usually this area doesn't even have materials for gas giants. So it's possible that somehow this is maybe a failed binary system, or a system where there was something that influenced the formation of the planets, and the planets got distorted and deformed, and possibly one of them ended up being a gas giant. So there's really no definitive explanation just yet for how this unusual but beautiful gas giant NGTS-1b was formed, and it actually really puts us in a difficult situation because we thought we understood the planetary creation. We thought it was actually relatively simple. You know, you have the ring system that sort of creates the planetary objects around the star, and we always thought that it was basically that simple. But using this sort of hypothesis, we can't really explain NGTS 1b. So it really makes it somewhat unusual. It makes it an exception to the rule. And so the scientists behind this paper, specifically Dr. Daniel Baylis from University of Geneva, basically said that, well, it seems to challenge our understanding of the creation of solar systems, and we don't really know how common these types of planets are in the galaxy, and this new facility will help us find a lot more of these objects. And with every discovery of these unusual objects and these exceptions to the rule, we're obviously going to be able to understand our own solar system a little bit better. And of course, it will help us understand how different planets form and evolve, and possibly even pin down a place that is going to be perfect for our own new home away from Earth. In other words, this will help us find an object that sometime in the future we'll be able to colonize. So NGTS-1b is actually one of the more unusual discoveries of 2017, and we'll hopefully be able to understand it sometime in the future. That's all I wanted to talk about in this video, and hopefully you enjoyed watching it, and hopefully you now know a little bit more about our universe, but specifically we now understand that we don't really understand the formation of planets as well as we thought we did. In the next video, we'll explore this in a little bit more detail, but most importantly, subscribe if you still haven't, come back tomorrow to learn something else, and share this video with someone who enjoys watching space videos. I'll see you guys in the next video, space out, and as always, bye bye.